This video focuses on double number lines. They're pretty similar to tables, except that a double number line will go horizontal and a table will go vertically. But also a double number line focuses on the space between quantities to give you more of a visual. I prefer a table and thinking about going straight to hitting the target. But double number lines are part of the standard for ratios and proportions. And they also have value, especially if you are strong at thinking in terms of fractions. And I'm going to go over a couple examples of how you can use a double number line and show the same problem with a table as well to make some comparisons. The first problem: the amount of sugary beverages Americans consume is a leading health concern. For a given brand of cola, a 12-ounce serving of cola contains about 40 grams of sugar. Complete the ratio table using the given ratio to find equivalent ratios. Okay, so it starts off with that 12 to 40 ratio. So we could think dividing both sides by 2. This ratio, the given ratio is really a 6 to 20. And then can be represented instead of, we're moving in intervals of 6, so instead of jumping up from 12 to 24, which would be multiplying by 2, we'll continue the pattern of moving by 6s, and every time we add 6 ounces, we add another 20 grams of sugar. Below it says a 1 liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would be in a 1 liter bottle of cola? Explain and show how to arrive at the solution. I'm going to represent this information using a double number line, which is what I want everyone to focus on for this lesson. To do that with a double number line, is with any number line, we're going to start at 0, 0. I'm going to put my ounces up here, my sugar down here. Okay, 0 ounces has 0 grams of sugar. In 6 ounces, we have 20 grams of sugar. And we're going to keep moving forward in our number line. I'm going to try and make the intervals pretty standard: 12, 40, 18, 60, and the question asks us about 34, so I want to keep going with my number line so that I can get to 34 ounces. 24, 80, 30, 100, 36, 120. Now, these types of problems get a little trickier because, well, 32 is or 34, I'm sorry, is nowhere to be found on our double number line, or if you were doing a table, it would be nowhere to be found in your table either. Using a double number line, though, we can imagine that 34 would be somewhere between this 30 and 36 point, and a little bit closer to 36. A double number line really takes advantage of fractions in your understanding. So 34, to go from 30 to 36, we're traveling a distance of 6. So 1, 2, 3, 4, 5, 6. Or we could have done it in different intervals if we want. And 34 would be about 1, 2, 3, 4, about right here. 1, 2. So the question is, how much sugar is that in grams? Well, I'm going to turn this more into like a thinking blocks model. And if we think about it as fractions, so it'd be like 31, 32, 33, 34. So it's 4/6 of the way there. And so to find out that value, we need to also think about Okay, 34 is 4/6 of the way to 36. What is that to 120? So what is 4/6 of the way between 100 and 120? Well, from 100 to 120 is a total distance of 20. So 4/6 would be about at this point right here. And what's the value of 4/6? To do that, you have to think, okay, we have 20. We want to know kind of the value of each block. So to find that, we're going to do 20 divided by 6, and that will give us the value of each one of the unit blocks. 6 goes into 20 3 times, and we have 2 remaining. But we're not going to think about converting this to decimals because we're thinking in terms of fractions and distance right now, and fractions are a little bit more precise. So we would say that we have 3 and 2/6 would be the value of each block, or about 3 and 1/3. And we would have 4 of these that are 3 and 1/3. So this would be 3 and 1/3, 6 and 2/3, 9 and 3/3, which would be 10, and then 13 and 1/3. So this distance over here would be 13 and 1/3. So our total distance, so the amount of sugar would be 113, because here's 100, and we're adding 13 and 1/3 more. That would be 4/6 of the way there. So 113 and 1/3 grams of sugar would be our answer, which would think, because that's where the 34 ounces would line up with. That's a confusing concept, especially if you don't have much background in working with fractions. So I'm going to show it side by side, representing it with a table. And with a table, we would just show our ounces and our sugar, and we could start with 12 and 40, or we could start with 6 and 20, however you want to get there. I'm going to just start with 6 and 20. And the question is, how do we get to 34 ounces to find out how much sugar there is? And that's what we're going to do. There's a lot of different possibilities if you're using a table to do this type of problem. You could go from 6 ounces if you wanted, and you could stop off at 2 ounces by dividing by 3. Once again, you'd be doing 20 divided by 3. And then you could multiply by 17 if you want to get to 34. Or you could think, I just want to go straight. Hey, it's not going to work out nice either way because 20 isn't going to divide by 3. So for this problem, I'm going to go straight from 6 to 34 by thinking, what do I have to multiply 6 by to get to 34? And to do that, I'm going to use my understanding of fact families and do 34 divided by 6. 6 goes into 34 5 times, which is 30. And I have 4 remaining. So you could call this 5 and 4/6, but it's going to be, you're not going to be able to multiply 20 times 5 and 4/6 very nicely. So I'm going to turn this into a decimal. Adding a 0, 6 goes into 40 6 times, which is 36. And then we have 4 again. So you can see this is going to be repeating. It's going to be 5.666, and it will go on forever. So to go from 6 to 34, multiply by 5.666. So we have to do the same thing to 20 times 5.666. And we can do that. I'm going to do it all the way up here in the corner. 5.6666 times 20. Well, we know 0 is going to be 0, 0, 0, 0, 0. So I'm just going to skip that. And I'll just put a placeholder in and multiply by 2. 2 times 6 is 12. 2 times 6 is 12, plus 1 is 13. 2 times 6 is 12, plus 1 is 13. 2 times 6 is 12, 13. 2 times 5 is 10, plus 1 is 11. Move the decimal place over, in my case, 4 points. 1, 2, 3, 4. And what do we get? 113.3, which is the same thing as 113 1/3. So these are two different ways to do it. You are responsible, though, for using a tape diagram. But you could also go straight to hit your target in a table. Using the same information on the second problem, we're going to do another example now. A school cafeteria has a restriction on the amount of sugary drinks available to students. Drinks may not have more than 25 grams of sugar. Based on this restriction, what is the largest cola in ounces? So we're using the same information from the last problem. So it's a relationship between 6 ounces and 20 grams. So we're going to use a double number line. 6 ounces has 20 grams. 12 ounces has 40 grams. And I don't need to continue my number line because it says that drinks may not have more than 25 grams of sugar. So 25 grams would be, we know 30 is in the middle. So 25 is going to be closer to 20. And if we think about this being 25, that is 25, 30, 35, 40. So if we think about this kind of as blocks here, I'm going to just represent this distance here. 25 would be 1/4 of the way there. It's 1/4 more. 25 is 1/4 between 20 and 40. 25 is 1/4 of the way there. So we're thinking, what's going to be 1/4 more ounces between 6 and 12? What would that value be? So we're trying to think about this. Okay, between 6 and 12 is a distance of 6. What does each one of these blocks represent? Because we're taking that distance of 6 and we're dividing it into 4 parts. So what is that value? So we're taking 6 essentially, dividing it by 4. Well, this is pretty simple. 4 goes into 6 one time, and you have 2 out of those 4 remaining. That's your 2 remaining. So it's 2 out of 4, or 1 1/2. So each one of these is like 1 1/2. So we're saying we have 6. What's 1 1/2 more? This would be 7 1/2. Oops. Which makes sense because then this would be 9, 10 1/2, 12. So what's the largest size? 7 1/2 ounces. If you made this with a table, we would have our ounces, grams, 6 to 20 ratio. We would want to get up to 25. Well, that's kind of tricky to go from 20 to 25. You could think I want to stop off here, and let's stop off at, we could stop off at 5 by dividing by 4 if we wanted to do that. 6 divided by 4 would be 1.5, as we just found out. That's what we did over here. And then we could multiply now by 5. And 1.5 times 5 would be 7.5. There are other ways to do. You could go straight from 20 to 25 if you wanted. I'm writing in white. 20 to 25, you could think 20 times what is 25? You could use fact families to get there. 20 goes into 25 0 times. So
you would just keep